Dear friends, in this video we are going to discuss about residual heat recovery equipment and systems. In previous videos we have been discussing about waste heat recovery importance and types. Now in this video we are going to discuss various equipment used in residual heat recovery and what are the types of equipments and how we are recovering the heat from the sources. So generally we are dividing the equipment into three categories. One is a high to ultra high temperature, that is 650 to 870 degrees Celsius. Low to medium temperature 120 to 650 degrees Celsius. Low temperature below 120 degrees Celsius. These are the three classification of waste heat recovery equipment based on the temperature. So the high to ultra high temperature, that is above 750 degrees Celsius, the recuperators is very similar to counterflow heat exchanger. The counterflow heat exchanger means both flow will be in opposite. One is in one direction, another one is in opposite direction, not in both or same direction. That is not parallel flow. Counter flow means the flow is in opposite direction, so that heat transfer will be more effective in the case of counter flow heat exchanger. Here it takes place between waste flow gases and the air through the metallic or ceramic walls, as we are seeing in the picture. Through the metallic or ceramic walls, duct or tubes carry the air to be preheated in the combustion chamber, whereas the other side contains the waste heat stream. So this is called waste heat recovery system. The air is coming in and going out, transferring the heat. Waste cold flow gases outlet is there, waste hot flow gases inlet. When the hot flow gases coming in, it will be hot. When it leaves, it will be cold. That is obvious. That means heat transfer took place. So this is called waste heat recovery using recuperator, that is heat exchanger. So there are five types of recuperators. One is convective recuperator, metallic recuperator, radiation or convective hybrid, ceramic, and the last one is a special recuperator called self-recuperative burners. So these are the five types of recuperators or heat exchangers. So the convective recuperator is the common type of recuperator where the hot flow gases are carried through a number of parallel small diameter tubes. That is a shell type of heat exchanger. We might have come across shell type heat exchanger where inside the shell there will be bank of tubes. In one tube air will flow and another tube the working material will flow. So the heat transfer will be taking place. In between we will be having the baffle plates to have or to retain the hot gases surrounding the tubes. So that is the convective recuperator. By means of convective heat transfer, heat will be transferred from one medium to another. This is called metallic radiation recuperator. So in the radiation recuperator, it consists of two concentric length of metal tube. Whereas in the convective heat transfer, we got shell tube where bank of tubes were there. Here we have the convective concentric tubes, two tubes of concentric. That is, one tube will be inside the another bigger tube. The inner tube carries the hot gases, where external carries the combustion air from the atmosphere to the air inlet to the furnace burner. The hot gases are cooled by incoming combustion air, which now carries additional energy to the combustion chamber. So we can imagine that two tubes are there. One is the external tube, another one is inner tube. So the inner tube carries the exhaust gas, whereas the external annulus carries the combustion air. By means of heat convective heat transfer, heat is taking place. Heat transfer is taking place. Third type is convective hybrid. For maximum effectiveness of heat transfer, hybrid recuperators are being used nowadays. It is a combination of radiation and convective recuperators. That is above said two methods. It is a combination of convective recuperator and radiation recuperator, which consists of high temperature radiation section followed by convective section. But this is more expensive than simple metallic type. But it is less bulky. That is the advantage of this one. Ceramic recuperators are another four type of recuperator. It is overcoming the limitation of metallic recuperator. Here the ceramic recuperators were built to join with the furnace cement. So the temperature limit for metallic recuperators is around 650 degrees Celsius. The exhaust gas temperature will be around 650 degrees Celsius. The recuperators cannot be used for gases that contain particulates, corrosive gases, and condensate vapor. So this is the disadvantage of the ceramic recuperators. Since ceramic recuperators cannot be used for gases that contain particulate matter, that is the dust particles, that is carbon particles, and corrosive gases which will corrode the inside tubes and the master vapor. These things should be avoided. It requires high maintenance, and we have to be very careful in avoiding the air leakages. So it may undergo thermal cycling. So while thermal cycling is happening, we have to be uh, precaution to avoid the air leakages, and that's why it requires high maintenance. Self-recuperative burners. This is a special type of recuperators in the form of burner. Recuperator is integrated with the burner itself, so there is no need to have hot air piping from the recuperator to burners. That's why it is called as self-recuperative burners. It is a cost advantage. The cost of the self-recuperative burner is comparatively lower than other types of recuperators. The regenerators, another type is, this is a special type, regenerators or regenerative heat exchanger. It is used for large capacity furnaces. Here it consists of two brick checker work chambers as shown in figure, and hot and cold air flow alternately. As the combustion exhaust gases pass through one chamber, the brick absorbs the heat from the combustion gas, and there is an increase in temperature. After the brick picks up heat, the flow is then reversed so that incoming combustion is passes through the hot checker work, which transfers the heat to the combustion. That is, in the two-way heating is taking place like a counterflow heat exchanger. The brick absorbs the heat and releases the heat. The brick will have the heat for more time. Retention of heat in the brick is more. That is, the retention time of heat in the brick chamber is high. That's why they are using the brick type of covering, shield. Here minimum two chambers are used. One is absorb heat from the exhaust gas. The other is transfer the heat to the combustion air. They are made from high temperature refractory bricks or specially designed ceramic shapes. The direction of airflow is altered about a fixed interval of time. You can now look at the picture of this regenerator with the furnace. As we have, it contains brick wall and chimney is there. Gas flow will be, alternate flow will be there. We can see the direction control wall. So it is the regenerator with furnace. This is the advantages than other types of recuperators. So thank you for watching this video. Thank you.